Hey guys, how's it going? My name is Cameron Caldwell. I'm here at LN Engineering. We've got here is our Ultimaker S5 3D printer. This is what we use for all of our rapid prototyping. If you're not familiar with 3D printers, this is a FDM style printer, which means it takes filaments of all sorts of different materials, PLA, ABS, and a variety of others, and prints it out and turns it into a solid print that you can then, handle and test fit and do whatever you need with it. So you start off with a 3D model, right? So you go from whatever you're designing. So I use Solidworks starting CAD and create an STL file, which is what the printer reads, and from there it generates its own coding to create the file, and then it prints it out.
And just like that, we are back. Engine Performance Expo, Lake Speed, myself and Charles Navarro from LN Engineering. Charles, our desktop is loaded with examples of 3D printed things.
Yep.
This is the latest, greatest.
Yep.
I'm super interested, honing and all of that. It's amazing to me, but the technology required is not something I'm going to be able to utilize. But like this, I could see this as practical application for so many people out there in the racing industry.
Exactly.
Oh, this technology has come a long way. Now, we were talking about with Roy yesterday. The Dodge guys back in 2001 were 3D printing manifolds. But the technology back then was we would put it on the engine, on the dyno, and you could make maybe 2 pulls and the gasoline would start eating away the material. So you had a couple of shots at it, that's all you had, and then you had to throw it away. So now you've got parts that are made out of different materials, and this technology, in the Samtech video yesterday, they mentioned it a little bit, and what I'll let Charles talk about it a little bit more is that one of my first experiences really using 3D printed stuff, not just seeing it on an engine making a manifold piece, was at Gibbs. We had a motocross dyno, so we were wanting to develop a 2-stroke engine oil. So we said, okay, we got this engine dyno here that's eddy current, controlled air, really nice piece, but it was made for a 450cc 4-cycle engine. Well, we got to put this 2-cycle engine on here. So we have to make these fixtures. So we did, one of the design engineers at Gibbs, and in SolidWorks, he drew up what he thought would need to be the right piece to fixture it up based on the measurements we gave him. And then we printed it and went in there and tried it. And of course, we know little things like, I've got to bolt this thing up here. Well, there's the hole, but the socket won't fit. So we need to open it up so the socket will fit. So just little things about how you can utilize 3D printed pieces so you're not killing the material that costs a lot of money, because spindle time, I'm not tying up a machine to make one part. I can sit here and print out the one piece. I can go over there and check it out to make sure it fits, make the adjustments, reprint those parts. So that was my first experience utilizing it to make that process go faster, and it was amazing. And I know, Charles, you use this every day in your business.
Yeah, we use our 3D printer daily. When my engineer approached me about buying a 3D printer, I was like, isn't that a toy? People download files off the internet, print widgets, and we're going to have stuff on everyone's desk that we're not using.
Right.
And it's the furthest from the actual case. A few items that I brought with me.
And before we dive in, the Porsches, your area, like where's this stuff going, just so people understand.
Yeah.
LN Engineering, what is your target?
My main business, we make parts for the automotive aftermarket for Porsche. vehicles primarily, and it's mostly engine components. We do some transmission, cooling, some racing parts, but it's mostly engine related.
Excellent.
So something we use daily, this is a rear main seal tool, and the factory tool costs well over $1,000, and we rent these out. But during COVID, everyone wanted to work on their car and rent the tools. We couldn't buy the tools, so we came up with a 3D printed version of the tool. Does the exact same job, and if we need more, we can just queue up the job at the end of the day. In the morning, we have a bunch of parts printed out. We can assemble it and ship out another tool the next day. And in manufacturing, we make all our products billet. We don't do any castings or anything. So from a concept, we'll design it in SolidWorks, go ahead and print it. We can test fit the part on the car, make sure it works, and then after we're done, we can then go out to the machine shop. And especially for a complicated part where we're starting with say a $400 billet piece of aluminum, we'll first go to a material that's called Ren board, and we can put it in there, no coolant, run the machine full tilt, the fastest it can go, make a test part. If we have a tool path wrong or something and it collides with the material, it won't damage the tool, it won't damage the machine, it's perfect. Once we've done that, we can go ahead and go right to the aluminum part. But like we were discussing earlier, there's lots of little details, like we make billet oil pans, and there's certain areas that we need to verify whether, like this is the ultrasonic oil level sender. We need to make sure that when you have the sender installed in the pan, you can actually plug in the harness, make sure that everything fits. So before we even make the finished part out of the Ren board or the aluminum, we know that all the sensors are going to fit in the right place, and you're going to be able to get the plug on and off.
So that's really important, because I mean, this is one of the key things in these cars, especially the electronic systems in these cars. If you don't have the correct fit or the plugs aren't right, it wigs the whole system out. You know, the last thing you want to do is be overfilling an engine because this thing's not right. So, like I said too, the spindle time in the shop, making a part from billet, you've taken time, machine time, which is valuable. You've taken material, which is valuable. And this way, you can actually print just a section. You don't have to make the whole part. Yep. You just make the section that you care about, and they can fit it up and make sure it works. So that process is kind of cool. And there's other little things like, hey, this. As opposed to having a metal part, you can actually make a 3D printed part. So you can actually make structural parts that actually work and utilize. Other things I know you guys do too was, like, let's say the header shield product. You actually make fixtures for things, not just parts, not just test pieces, but you can actually print components that can be fixtures that you can actually...
Correct, yeah. It's one of the processes that we developed. We make integral thermal management for exhaust systems, and like all the Ford GT race cars, that's something that we do for those race cars. And complex shapes, we can go ahead and take the exhaust system if we have a model for the exhaust, or if we need to draw something up, we can go ahead and make a fixture that 3D printed with, and then we could add in steel components and then fill it with resin, and we can make a very inexpensive die to stamp out complex shapes. So very low cost, we can 3D print the dies, go ahead and press the complex shapes, then assemble the thermal management system, and it speeds up rather than having to hand lay pieces of material to make those shapes and form them. We can do it just in one operation, and that's a great one. And it's very inexpensive, very quick to make a die. The materials to make those dies it's way cheaper than buying a chunk of aluminum, having the machine.
See, what Scooter didn't tell you was most of that $750,000 was molds. Right. I mean, when you were making a plastic part back then, it had to be injection molded. So the cost of molding in the dies, that's what the big cost was. And either you're in or you're not, you're out, right? So now that wouldn't even be the case. You could literally design it, 3D print it. Is this going to work? Yeah, it's good. Heck, you could even probably make some production prototypes, let some guys test it and say, oh yeah, this is going to sell. Okay, now we can find a way to scale the production up and do it. You didn't have to be as risky, right? But of course, Ron really liked being the risky guy.
and there's like there's some examples here that it was an idea to make something. We were able to test fit. This was a throttle body adapter, and it didn't work. The adapter did, but adapting a throttle body from an application didn't work. Well, we didn't take the time to go ahead and make this billet out of aluminum, then have that cost and the time, and to find out that it didn't work.
The whole concept
was
a bad concept.
It was a bad concept. We just couldn't do it. But it saved time. And other examples, someone will ask us to design something, we'll go ahead and print it, they'll test fit it, and then they decide they want to change directions. Well, they're not as invested in the project as if we had gone ahead and made that manifold, billet, and then CNC ported it and gone through all that versus just a as printed part.
Right. And the thing I'm thinking about right now, right? 2021 supply chain challenges, right? Which we're going to talk about later today. We're going to have the round table, and you're going to be part of it. Yep. That you can't really afford right now to throw away good raw material. If I've got a piece of billet that I can turn into a part that it already has an order for, I don't need to waste it test fitting something that may or may not ever be something. So it's just, being thoughtful. Back to Warren, right? Why do all these things come back to Warren?
It all comes back to Warren.
Right? It's like that thought process. Think it through a few steps. And I think that's what's really kind of revolutionary about 3D printing. I absolutely love this idea. To be able to pivot that quickly.
Yep.
To, okay, wait, we need this tool for the part we already sell. But this tool's expensive, or the tool's unavailable. Wait, I can make my own. And now I'm not even stealing a resource that would be going into making other parts. I'm just making it. It's just like it literally does grow.
Yeah, and it can run at night. You just load up the job and just let it go all night. And again, you come in the morning, the parts are done, and
grow.
Yeah.
And you're growing them.
Well, here's the thing. A lot of people don't know this. If you've flown on a jet plane in the last probably 5-7 years that had a GE engine in it, the blades were 3D printed. They've been doing this stuff for a long time, because one thing about 3D printing is it lets you make shapes that you can't make with the tool. Like internal parts where you'd have to make it 2 pieces and then put it together. You have to do it. I mean, when the guys at Oak Ridge, again, one of the other places that's been an immense blessing to be able to have been in their orbit is Oak Ridge National Laboratory, which is literally an hour and a half from where we're sitting right now, which is where they actually did the uranium enrichment for the Manhattan Project. So government research facility. I think there's over 1,000 PhD physicists and scientists on that campus. Smartest people. Yeah, man, when I'm there, I'm the dumbest person there by far. Like, not even close, right? The janitor's smarter than me. I guarantee it, right? But they have been doing 3D printing for a while. They 3D printed a working backhoe. All the articulation joints, all the tubing, because in a hydraulic system, the number one area of failure are the joints between the hoses. Well, by 3D printing it, there are no joints. There are no failure points. So they literally have 3D printers that are the size of a trampoline or bigger. I mean, they can 3D print very, very large parts. So I think 3D printing may be something new to you that you've heard about, but it's now. It's not something in the future. It's happening now in major industry, and I see it only growing.
Even from a practicality standpoint, even if you're not making a part that you can physically put on a car or an engine and actually run, which is being done.
Oh, I mean, when I went to Formula One teams, they are literally 3D printing parts. They're putting on the cars and racing that week.
Yeah, but from a everyday practical use standpoint, like another thing that we use our 3D printer, we make little fixtures for our laser. So when we need to etch parts, that these are all, you can't probably see it, but there's letters and numbers which indicate where this needs to be bolted down on the table for the laser. Then we can just go ahead, load the file program, and just start lasering parts. Literally, however long it takes you to put a few screws in this and open a file and hit go, you can start lasering parts. And we have fixtures for every single one of the parts that we make that gets lasered. to make that process quick, because otherwise you're sitting, you have to zero the laser, dial it in, and then when you put the next part down, is it going to be lasered in the exact same space?
Sure.
Yeah.
So
Yeah,
just
so
a
precision.
jig, if
Yeah.
you will.
Yeah.
To pick up the speed of manufacturing, which time is money.
Yep.
Right? Like, you're going to become more efficient. You're going to do better. So where's this going? I can't help but think about, and previously we had a conversation, they're 3D printing houses, they're 3D printing so many things. There's big printers, there's small printers. But in your application, like, where are we in the arc of figuring out how useful this technology will be?
Well, the next thing that we're internally looking at are metal 3D printed parts. And there's, like Lake was saying, there's certain geometries that you can't do billet, that you can, casting is you're not going to be possible with a casting, or done well with a casting, and you can really design anything you want.
Right.
Any complex geometry, internal passages, all that detail, you can metal 3D print that part, and you can have it metal 3D printed. Then you can go back and machine the part.
Right.
So you can machine all the critical surfaces.
And because that's one of the limitations right now of, they really call it additive manufacturing, when you get into printing metal parts. I guess that's maybe the technical terminology there, that this is the 3D printed plastic parts. We kind of call that 3D printing. When you get into making structural components that would be used, not fixtures and things, they call that additive manufacturing. And one of the cool things about it is, like Charles said, you can make shapes you couldn't make otherwise. But the finish isn't, like you see these. It's not as nice as a machined piece. But they're working on technologies for post-printing to achieve that same level of surface finish. Because, as we all know, surface finish is really important. But then there are some interesting metallurgies, essentially, you can print. So I know there's, Mala, they have a video on the web, on I think their website somewhere on YouTube. They've actually started 3D printing pistons. So they, as opposed to having a 3D, or say a forging for a piston that you then machine, they 3D print a near net shape, then they can finish machine it. So they're still machining it, but as opposed to starting with a forging, they're starting with a 3D printed object that's closer to what it needs to be. So there's a lot of things coming, I think, in our industry, where we're going to start seeing more of this sooner rather than later.
And what they talk, having been to a few additive manufacturing conferences, what they kind of talk about, you have to just throw away the mindset. You have to take it, you can make a part, do the FE analysis, and let the analysis tell you where the material needs to be to have the optimal strength. And you can run models, and the final design for something might look totally different. There's software that can help do iterations and calculate where you need to have a truss, or you have to have support. And it was amazing to see that the final product might look totally different than what we're used to seeing. That because we're constrained. Well, you have a tool path.
Right.
You can only get a tool in a certain way, and it has a radius on it. You have to throw that mindset away with additive
That's still going to be hard. That's going to be hard.
You have to just forget about what you already know, and just go in with a blank slate when you're thinking about additive manufacturing and what you can do with the technology.
I know there are some people right now that are using additive manufacturing to create molds for engine blocks and things like that. That's a way you can actually get parts. You basically, there's the traditional sand casting, right? But you can also make total loss molds, where when you pour it in, it's gone. But you can 3D print that thing and have much more accurate. So there's making the parts, helping other parts be made better. This is the future, right? So I think that we've got to continue to really look at, which is why we wanted to have this as a segment, because this has got to be on your radar. If it's not, it needs to be on your radar.
And for your business, the Porsche owners out there, like, they want to customize, they want to go fast, and you mentioned just the tool itself was over $1,000 just to an install tool. That is something that for you guys to buy a bunch and rent them, or for the homeowner, the car owner, to do it, they're not going to be able to do it. So you guys have kind of like worked to bring that cost down and make it more affordable through the technology.
And accessible.
Yeah. Affordable, accessible through the technology.
Exactly.
So you got 10 people doing it instead of 2 people doing it, and that's awesome. It's like democratizing the fun. Yeah. And all because of technology. No, this has been amazing, and so much more coming. Like, as we see it, it's intriguing to me, because this is not just an automotive technology.
Correct.
No, exactly. I think it's obviously they people like Boeing, GE, they're using it today in aviation, aircraft, aerospace stuff, and already very high levels, NASCAR, Formula One. This is current technology. This isn't something future, it's current, and I think it's going to continue to make its way down into our levels where, hey, this is how you do stuff, because it will save you time, right, man? Because that's the thing, time is money, and we know that. In today's world, it's even more important to be more efficient with your time because there is so little time and there's so much happening.
But I'm sure you made a bunch of little tchotchkes for the desks also.
Oh, sure. Yeah. It gets used. Yeah. Trust me. There are some tchotchkes floating around.
Some keychains and things like that.
The plastic is cheap and the electricity is cheap. So it's.
And I know the people that you're working with, I'm sure, like, I can make this. Let's have a cup holder. Oh, all right, let's print it up.
The cup holder for the Haas. Or a holder for your air nozzle. They're all across the shop. You'll find little. They think it'd be neat if we had this, and you can just go ahead and draw something up in a few minutes, print it, and then there's air blaster holders on all the machines to their shop. They're all 3D printed, stuck to the side of the machines. It's endless. The usable things you could do with 3D printing.
Bottom line, great investment and to look forward to it. But I like the fact that you were skeptical. Yeah. Frankly, like that demonstrates to me the how good a deal it was. Like someone that's like, are we sure? Yes, not only are we sure, we dove in, and it has been a much better deal.
Yep. Exactly. So,
excellent. Well, Charles, you'll be back for our roundtable discussion, LN Engineering as well. And now we're going to thank our sponsors for a few minutes. We'll see you later at the roundtable. And just a big shout out to the people who made it all possible. Obviously, I know we got a lot of people watching on NHRA.tv. And to Engine Performance Expo. To you NHRA.tv folks out there, just want to remind you that you'll be able to participate. Not that you should leave NHRA.tv, but if you do have a question, go to EnginePerformanceExpo.com, and then you can chime in on the show, whatever your questions are. EngineLabs.com, great job with a great story and coverage of this event. Thank you guys, appreciate you. We're having a great time, hopefully you are too. And Race Engine Technology out there. Rottler, Total Seal Piston Rings, CWT, Strab Technologies, Pro Charger, had a couple great bits yesterday with the Pro Charger folks. Blueprint Engines, Edelbrock, Morel Lifters, Holly, Goodson, Valvoline, Ultrasonic, Dart, Elgin, AERA, Comp Cams, ARP, Driven Race Oil, Mala, Motor State and Summit Racing Equipment, plus our contributors, the folks at samtech.edu, Petty Enterprises, LN Engineering, just heard from Charles, and just so much information there. Thank you so much. Shaver Specialties Racing Engines, Robert Yates Racing Engines, EFI University, that's Ben Strader, who really got us all started off right. And I want to keep mentioning the 50% of all eligible purchases going to the Pretty in Pink Foundation, which supports uninsured and underinsured breast cancer patients, from the folks at Scott Performance Wire for the month of October. Go to sparkplugwires.com to find out more information. If you need spark plug wires or don't need them, now is the time to get them, because such a great promotion going on. But back in the studio, it is time for something that has become part of the Engine Performance Expo, and it is a Lifetime Achievement Award. Like last year, what an honor it was to get Ed Pink up on the screen and present the award to Ed Pink. And we're gonna try to continue that trend right now, and this is going to be something that I think everybody remembers for a long, long time, our Lifetime Achievement Award.
Exactly. So we got to give another Ed a Lifetime Achievement Award, because those Southern California guys, they started this whole thing,
so
right?
Cal represent.
They did. So, as you know, because of Hidden Horsepower,
yes,
earlier this summer, I had the opportunity when we were out filming some of these videos. I just happened to be in Los Angeles the week that a certain Ed turned 100 years old. And, fortunately enough, I was able to go to his birthday party. So, this year's Lifetime Achievement Award, who else could we possibly give it to other than Ed Iskenderian?
Wow.
The Godfather, the Cam Father, the heart and soul of Isky cams. So this year's representative is going to be award given to Ed. So I already talked to Richard and Ron, his sons, the other day, and said Ed couldn't make it out here to be here live. You know, he is 100, so we got to give him.
He turned 100 years old, and
right.
you know, the party, of course, which I believe we're going to show.
We're going to show
the video, and I've seen him out at the NHRA, and he is out there meeting people and hanging out and moving and grooving and doing and all this stuff. If only we could be that energized at 100 years old. Let's check out the video.
Yes, let's do it.
Of our Lifetime Award winner here at the Engine Performance Expo, Ed Iskenderian.
Birthday to you. Happy birthday to you. Happy birthday, dear Ed. Happy birthday to you.
Well, filling a cylinder all the way would be 100% while I'm at the efficiency. And I didn't realize at the time, but that's hard to do at high speed. Maybe at low speed, so that's the first thing we learned from Whitfield. So after the war, I decided I'd like to try that cam grinder because the cam grinder got a lot of, when the engine builder, we didn't have any engine builder, but when the guy built a good car and set some kind of records, the cam grinder would get a prize and come credit. They want to know what cam was in there. And I thought I was horning in on Winfield's business because he was nice to me. But actually, he would have helped me then, even then, because he was retired. And so later year, I started going out maybe every 6 weeks. I said, I better learn all I can from him. Because he's got so much knowledge about the old days. Do you mind if I start paying you? Because I'm learning a lot of things I'd never know otherwise. So I must have paid him about the right amount because he never said it was too much to get him. Yeah.
Wait, that was about your part of your education.
Yeah. So cam grinder gets a lot of credit for someone that built a good engine, and some engine builders can make a bit bum cam look good.
Ed Iskenderian, Lifetime Achievement, and we've got this award. This is such a great award. 100 years old, though. I don't think he needs this, but we're happy to give it to him either way. And you got to be at the birthday party, Lake. Like, that's, I'm jealous.
When you get to be buddies with Ron Shaver, you get to be buddies with everybody. That's kind of a cool thing. So they had Ed's birthday party at Taco Tuesday. So they have this place they go to every Tuesday for tacos. It's not like Warren, right?
Yes.
So, you know, this hat isn't as cool as Chris Radke's red hat for being in the 200-mile car at Bonneville.
Yes.
But this is my red hat, which is signed by Isky himself, right? Because basically he had a trivia question. So they brought some of their gifts, and the whole thing, he was signing autographs for everybody there at the little birthday party gig. And they said, okay, questions. Who had a little trivia question?
You won this. This is a prize.
I won this. So this is, so
what was
Chris
the question?
What question was, what city was his original shop? Because they're in Gardena, California. And I knew that LA was pretty small 100 years ago. So there probably wasn't a lot of suburbs. So I just randomly guessed Los Angeles, and I was right. So I got the hat. So this is my
Put it on.
red hat.
Look
so
at this
there you
guy.
go, Chris, ARP. I got my red hat. Not as cool as his, not as fast, but I'm still going to wear it, though.
I don't know. I think it's pretty cool as it is. I mean, the Lifetime Achievement, the Cam Father, and someone who is motivation for all of us because he's still going.
He is, and he's telling stories. Like, so Scooter was saying, hey, when we first started grounding those cams, we were pretty rough. You heard Ed saying, Ed Winfield told him, oh yeah, you got to do this lash ramp, and Ed's like, man, I don't have money for that. just cut it out.
Well, exactly.
It worked out for him.
And it did. It did. And congratulations to Ed Iskenderian. And thank you for your service to this industry and just all that you've put in. It's amazing stuff. And, don't be afraid to fail, right?
Here's another one. It's the lesson. We keep learning these things. It's like, boom, over again. Don't be afraid to fail.
Simple as that. Well, this has been great, and we're going to keep on going. So if you're out there on EnginePerformanceExpo.com, remember, Q&A sessions coming up. Be ready with your questions. If you're watching on NHRA.tv, congratulations to you. Just some big breaking news. Want to drop it in there?
Yes.
Tony Stewart Drag Racing just announced Leah Pruitt, Matt Hagan, the team for next year. And to have TS involved in NHRA drag racing, I think is something that is very exciting to a lot of folks out there. Just shows the expansion of this motorsport that'll be here in town this week. So if you're in the area, come on out. All right. It was very great speaking with Charles, talking a little bit about 3D printing. Automation. The idea of leaving the shop, heading home, and things happening that are going to make you money. Putting automation and technology to work for you. Check it out. We'll be back right after. What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.